All right, right now we're going to cover how to write down compounds if you're working with an ionic compound, the formula. Okay, so first of all, I have stuff pre-written here, so as I go along, you'll be pausing and copying things down. So first of all, what is an ionic compound? So an ionic compound is a bond that forms when you have a metal element bonded with a non-metal, or what we also call other things called polyatomic. So your metals, again, are on the left of the stairs on your periodic table, okay? And your nonmetals are on the right of the stairs. So when you have a metal from the left bonded with something from the right, the nonmetals, or one of these polyatomics here, this is a polyatomic list that you have. Polyatomics, poly means many, atomic means atom. So when you have more than one atom together, and they act as if they're just one type of element. So ammonium, NH4, it's a nitrogen with 4 hydrogens. They're together. They act as if they are stuck together as if they're one element. Okay. So whenever you have a metal with a nonmetal or with a polyatomic, you are working with an ionic compound. Ionic compounds, to help you figure out if you're working with an ionic compound, they always start with a metal. So some element from the left of the stairs besides hydrogen. Okay. All right. So here are the steps. We'll go through the steps, and then we'll practice them down below. So first, you're going to find the metal that you're working with in the particular problem on the periodic table. Find the charge at the top. So for example, the charge is like +1, +2, +3. Those are your charges for your metals. Okay. You're going to write down its symbol with its charge at the top right. So for example, if we are working with magnesium in our compound, we'd write Mg +2 because magnesium has a +2 charge. Okay. Then for the nonmetal part, the anion, you're going to find that on the periodic table. So that's the thing that ends in "ide." So for a nonmetal on the periodic table, its charge, find it, and at the top of the column, write down its symbol with its charge at the top right. So if we were working with fluorine, that'd be F with a -1. Because fluorine, which comes with fluor, you would see written as fluoride, so as an ion, but fluorine has a -1 charge. If you're working with a polyatomic, that's something that usually would end in an ite, or if you're working with cyanide or hydroxide, that's on your polyatomic list. Write down the symbol in parentheses with its charge. So for example, if we were working with cyanide, we would see, cyanide is Cn with a -1 charge. And you should put the C and the N in parentheses. That'll help you form your formula correctly. Then you're going to what we call crisscross charges. This is a shortcut way to figure out what subscripts, how many of each element would we need bonded to each other in order to make a neutrally charged compound. So this crisscrossing charge step determines little subscript numbers, the numbers at the bottom, and we ignore the plus and minus signs that your charges had. Okay, so we'll see this in action right now. Okay, so for example, if I want to do this with lithium phosphide, I'm going to first kind of separate here, okay, and say, well, lithium is an element on the left, so that is a metal. Phosphide, things that end in "ide, means that's a nonmetal on your periodic table. So phosphide, again, on the right-hand side, that is definitely a nonmetal. Okay, ends in "ide." Okay, so I'm going to first look up my element lithium and write down its charge. So I have Li +1. Okay, phosphide comes from phosphorus, which is a -3 charge. Okay, so P -3. Okay, and then we are going to crisscross the charges, which what that would look like is the 3 is going to go behind lithium, and the 1 is going to go behind phosphorus. So to write that as a compound, we would write Li. The 3 gets put behind lithium. That's a subscript 3. We ignore the negative sign. So that means we have 3 lithiums bonded to the phosphorus, and we have 1 of it. So we don't need a number. Whenever you're working with 1 in chemistry, you don't need to write down that 1 for for a compound. Okay, so this is our compound lithium phosphide. In order to form lithium phosphide, you need 3 lithiums bonded to 1 phosphorus. Okay, sodium oxide. Okay, sodium, just to double check, sodium is on the left, so that is a metal. Oxide comes from oxygen, that's the name of the ion for oxygen. Oxide is on the right, it is a nonmetal. Okay, I'm going to look up sodium and its charge. Sodium plus 1. And oxygen minus 2. Okay. I'm going to crisscross the charges. So I'm going to write my Na and I'm going to write my O. So the 2 gets put behind the sodium. So that means I have 2 sodiums. And I have 1 oxygen that gets put behind oxygen. So 1, I don't need to write that down. Okay, so Na2O. So I have 2 sodiums that have to bond to 1 oxygen in order to form a compound that's neutrally charged with no charge. All right, next one, beryllium chloride. All right, beryllium is on the left. It's a metal. Okay, metal. Chloride ends in IDE. Sounds like chlorine. That's the ion name for chlorine. So chloride's on the right. That is your nonmetal. Okay, beryllium. Look up the charge. That is a +2. Chloride, chlorine, is a -1. All right, crisscross those charges. So I'm going to write out my work here. I'm going to write out the beryllium and the chlorine. And the number that's behind beryllium will be a 1. So I'm going to leave that blank like that. That means we have 1 of beryllium. Then the 2 chlorine. So after the 2. So I kind of left the big space there next time. Whoops. So BeCl2 is our compound. All right, next one, calcium sulfate. This one's a little different here. All right, calcium. Calcium is a metal on the left. Sulfate. Okay, things that end in ate or ite are for sure, dead giveaway, things that are on your polyatomic sheet. So sulfate, there we go, right here, is SO4 minus 2. So I'm going to write, so that's poly. So calcium has a +2 charge. Okay. Sulfate, from your polyatomic sheet, we're going to write parentheses SO4 minus 2. See, SO4 minus 2 sulfate. Okay. All right, we're going to crisscross those charges. This one also has a little kind of catch to it. All right, CaSO4. Now notice here we have a 2 being put behind calcium and then another 2 being put behind sulfate. Now, special case scenario here, when you end up with something like a ratio like 2 to 2 or 2 to 4, something where you can reduce it, you want to reduce it. So a 2 to 2 ratio, 2 calciums bonded to 2 sulfates, would be the same thing as a 1 to 1 ratio. So in math and science, we always like to reduce when we can. So this would really be 1 calcium bonded to 1 sulfate. So that would be the correct answer. Okay. All right, copper 2 chloride. Ooh, we see something different here. We see a Roman numeral. Well, first of all, copper is a metal. Okay. Chloride comes from chlorine. That is a nonmetal. -1 charge. So that is a nonmetal. Now, copper, if you look it up, there is no charge above it. Okay, so it's a transition metal. It changes its charges. So this copper is saying, hey, you have a +2 here. Chlorine is a -1. We crisscross. So we end up with 1 copper and 2 chlorines. Okay. All right, last one, magnesium hydroxide. Magnesium's on the left. It's a metal. Hydroxide. Okay, that's not hydrogen. It's not oxygen. It comes from a polyatomic hydroxide. Okay, OH -1. So that's a poly. Magnesium has a +2. Hydroxide, parentheses OH -1. Crisscross those charges. So we have 1 magnesium bonded to 2 hydroxides.